Greetings, welcome to another lesson in chemistry. Today we're going to be solving a double replacement reaction in aqueous solution, and the problem is read as an aqueous solution of lead 2 acetate is mixed with an aqueous solution of lithium chloride, causing a double replacement reaction to occur. The left-hand side of the skeleton equation is provided for you and is this set of symbols there. Our first task is to write the skeleton equation, including states, in this rectangle. Well, we're already given the left half of the skeleton equation, but before we write the skeleton equation out, I like to think about what are the various ions that are involved here. And I'm just going to make a few shorthand notes up here in the free space. We're told it's lead 2 acetate, so one of the ions will be lead with a 2+ charge. Acetate. Well, if this lead has a +2 charge, that means all of this mess here has to have a -2 charge, such that the overall compound is neutral. Well, if this anion part of the compound has a -2 charge, and there are 2 acetate ions, that tells me that acetate itself must be an anion with a charge of only -1. So let's write that out just as a little side note here. C2H3O2 has a single minus charge on it. Lithium, we know, is a group 1A alkali metal. That's easy. That's a plus charge on the lithium ion. The chloride ion has a minus charge. So there's our little crib notes for what ions are involved in this reaction. So let's go ahead and write in the skeleton equation, starting with the left-hand side that we've already been given. We're also asked to include states, so that will be a notation of, aqueous, aqueous, and so forth. So all we've done is rewrite the left half of the skeleton equation, inserting these state designators aqueous and aqueous. The right-hand side is more of an unknown force at the moment, but remember that this is a double replacement reaction, which means the cations are going to trade anions. So in words, we could say that lead 2 acetate plus lithium chloride should yield lead 2 chloride plus lithium acetate. So notice the swapping of the lead and the lithium. So let's think about what we just said. Lead 2 chloride. Well, lead 2 has a +2 charge. Chloride has a -1 charge. So we're going to need 2 chlorides in order for the overall charge of lead 2 chloride to be 0. So let's write out lead 2 chloride. Now what we don't know yet is whether that's aqueous, solid, liquid, gas, or so forth. Well, being a compound of lead, we certainly believe it will not be a gas or a liquid. It's a salt, so it's most likely either going to be a solid or a solid that dissolves in water, which would make it aqueous. So referring to our solubility rules for ionic compounds, we see that chloride salts tend to be soluble, except for compounds of silver, lead 2, and mercury 1. Well, that's lead 2, so this lead 2 chloride is insoluble, meaning it's a solid, and it will precipitate out. So let's put solid there. And the remaining compound will have to be lithium acetate. Well, we see that lithium has a charge of +1, acetate has a charge of -1, so we just need one of each. Lithium acetate, C2. And again, we're faced with the question, solid, liquid, gas, aqueous, what is it? Well, consulting the solubility rules for ionic compounds, salts of alkali metals and ammonia are soluble. Well, lithium is an alkali metal, so this salt should be soluble, meaning it will be aqueous. So there we have the skeleton equation for the reaction lead 2 acetate plus lithium chloride yields lead 2 chloride plus lithium acetate. When we come back, we'll write the balanced chemical equation. Hello again. We now have the skeleton equation for this reaction. Now we're asked to write the balanced chemical equation including states. So what that really means is take the skeleton equation and put in the appropriate coefficients in front of however many of these compounds we need coefficients in front of. What that does not give us a license to do is start changing any of these subscripts. We can't change any of these subscripts now. They're frozen in our skeleton equation. So the first step in writing a balanced chemical equation is to write the skeleton equation itself. So let me recopy our skeleton equation into the space below. Okay, we've rewritten the skeleton equation, and the only remaining step is to insert coefficients where needed to balance our chemical equation. Well, I'm going to switch over from pen to pencil for this part of the task because I often make mistakes and I need to erase and update these coefficients. So let's just start from the left. We have one lead atom on the left-hand side. On the right-hand side we have one lead atom. So far so good with the leads. Acetate ions, I have 2 acetates on the left, denoted by that 2. Over on the right-hand side I only have 1 acetate ion, so I suspect I might need a 2 there, but I'm not going to write it there yet. Let's look at lithium. I have 1 lithium atom on the left, 1 lithium on the right. How about chlorine? I have a chlorine atom on the left, but on the right I have 2 chlorine atoms. So I suspect I might need to put a 2 here to make the chlorines balance. So let's go ahead and write in those 2's that we thought we might need. So need a 2 there to give us our second acetate, a 2 there to give us our second chloride. Now let's see if we balance. 1 lead, 2 acetates, 2 acetates, 2 lithiums, 2 chlorines, 2 chlorines. Everything is balanced, so we have written the balanced chemical equation. Thank you. Hi, welcome back. So we've developed a balanced chemical equation showing all the states. Mistake, lead 2 chloride is not aqueous. That's actually a solid, so we had a transcription error there when we copied the skeleton equation down from here to here. This S mysteriously became AQ, but it should be S. I hope most of you caught that mistake as I was making it. In fact, I'll just say I made that mistake on purpose to see who was paying attention. Yeah, that's it. So we're now asked to write the balanced complete ionic equation including states in the rectangle below. The trick for writing a complete ionic equation is to take every one of our compounds that has AQ after it and rewrite it here, but only in a form that shows it dissociated into its ions. So for example, lead 2 acetate. Well, that's aqueous. So down here I would have a lead plus 2 ion and 2 acetate ions. Lithium chloride is aqueous. Down here I would have 2 lithium ions and 2 chloride ions. So let's get started with that. On the left side we have a lead ion. That will be aqueous. We have 2 of these acetate ions, and it does not remain as this acetate with a subscript 2, but you should bring the 2 out in front to designate, yes, 2 separate acetate ions. Plus 2 C2H3O2 acetate ions, and each of those has a minus, and they are aqueous. So we've shown now lead 2 acetate dissociated into its ions, plus 2 lithium ions and 2 chloride ions. 2 lithium ions plus 2 chloride ions. Yields. Now we have lead 2 chloride, the solid. Well, a solid is not aqueous, so it will not dissociate as a product, so we'll leave it as a solid. We're leaving it as it is. So we'll just rewrite it, PbCl2 solid plus the rest of our products, 2 lithium acetates, aqueous. So we'll break that up or dissociate that into 2 lithium ions and 2 acetate ions. And there we have the complete ionic equation including states. Just to review it, we have a lead 2 cation, 2 acetate anions, 2 lithium ions, 2 chloride ions, yielding lead 2 chloride, the solid, plus 2 lithium ions plus 2 acetate ions. That is our complete and balanced ionic equation, including states. Thank you. When we come back, we'll tackle writing the net ionic equation for that reaction. Welcome back. Up to now, we've developed this balanced, complete ionic equation for the reaction. Reactants here, products here, and now we're asked to write the net ionic equation, including states, for this complete ionic equation. And what we want to do is find all aqueous ions that exist on both sides of the equation and just simply lightly cross them off because they are spectator ions. They will not be part of the net ionic equation. So let's just start here at the left. We have a lead 2 ion that's aqueous on the left. On the right hand side of the arrow, I don't see any lead 2 ions that are aqueous. So we'll leave that as part of the net ionic equation. Also on the left, 2 acetate ions. Do we see anything like that on the right? Yes, right there. 2 acetate ions, 2 acetate ions. So I can lightly cross them off. Lithium, 2 lithium ions on the left, 2 lithium ions on the right. Both are aqueous. I can lightly cross them off. And 2 chloride ions on the left that are aqueous. I don't see any chloride ions that are aqueous on the right, so I have to let that one stay. So I'm ready to write my net ionic equation. We're going to have whatever isn't crossed off, which is lead-2 aqueous plus 2 chlorides, also aqueous, yielding lead-2 chloride solid, plus nothing else. So there we have our net ionic equation, but let's just double check it from 2 points of view. First of all, the number of atoms of each element on each side. So we have a lead atom and a lead atom. 2 chlorine atoms, 2 chlorine atoms. So we're good from that point of view. Now how about charges? On the left-hand side, we have 2 positive charges with the lead. We have 2 negative charges with the 2 chlorides, so positive 2 and negative 2 cancel each other out, giving us a net charge of 0 on the left. And then for this solid compound, well, all ionic solids are neutral, so there's a net charge of 0 on this side. So charge of 0, charge of 0. So this equation is also balanced from the charge point of view. So we're done. We've written the net ionic equation. Thank you and goodbye.